Welcome to myprojectbazaar.com.
Our product title is Comparative Analysis of 3, 5 and 7 level inverter using Space Vector PWM. Next, we see about the abstract of our product. In this proposed implementation, we did using a fuzzy logic controller instead of Space Vector PWM controller because the students' requirement is for that only. So we developed that kind of work in this process only, and also corresponding output only here we provided. The abstract is the above concept brings out the method for the multi-level inverters for generation of space vector modulation pulse width modulation signals. The small triangular formed by the adjacent voltage small space vectors are called sectors. Such 6 sectors around a voltage space vector forms a hexagon. Around a voltage space vectors from a hexagon called subhexagons. The space vector diagram of a multi-level inverter can be viewed as a composed of a number of such subhexagons. In the proposed method, we are finding the switching sequence to the two-level inverter, and this can be extended to any number of levels of inverter. Space vector pulse width modulation technique is used in this proposed system, by which these two-level vectors are translated to the switching vectors of the multi-level inverter. By adding the center of the subhexagon of the two-level vectors, the scheme is explained for a 5-level diode clumped inverter, and experimental wise this diode clump inverter is simulated in the MATLAB simulating environment. Next, we see about the flow diagram of our process. In this flow diagram, the input source is a DC supply. The DC supply is fed into the inverter circuit through a cascaded multi-level inverter topology. In the inverter circuit is used for conversion of DC to AC conversion, and in this the inverter having 6 power electronic switching devices. That switching devices is triggered by using of space vector PWM technique in the base paper, but in the implementation design we using fuzzy logic controller instead of space vector PWM technique. And also the output of the inverter circuit is fed into the load. The load may be a resistive, inductive or capacitive load. In the topology is to overcome the disadvantages of conventional topology, developed cascaded topology, the voltage values and corresponding switching states. This inverter is able to generate all voltage level except it is needed to use an additional DC voltage source with the amplitude and 2 unidirectional switches that are connected in series with the cascade topology. The developed cascaded inverter that is able to generate all the levels in the inverter power switches S1 and S2, and DC voltage source have been used to produce the lowest output level. The amplitude of this DC voltage source is considered, which is equal to the minimum output level. The output voltage level of the each unit is indicatively the number of power switches is equal to the number of IGBT power diodes and driver circuits. Another main parameter is calculating the total cost of the inverter is the maximum amount of blocked voltage by the switches. If the values of the blocked voltage by the switches are reduced, the total cost of the inverter decreases, as is obtained using this proposed configuration. Next, we see about the running process of our product. In this proposed implementation is done in MATLAB simulating environment. First, open the MATLAB window and create a new model file. After creating a new model file, we are arranging the elements as per the circuit diagram and also arranging the blocks from the simulating library browser. In the simulating library browser, we mainly used 2 blocks such as sim power system block and also commonly used block. Those 2 blocks is used to view the output waveform and also the elements arranging as per the circuit diagram. After connecting the scopes from the commonly used block and which output is viewed to see. So that area we connected the scope, the output will be shown in that scope. Then click the run icon, the output will be displayed in the corresponding scope. So first one is the output power waveform in the overall source, and next one is the output current waveform and output voltage waveform, and next one the current waveform, and this is the each capacitor across the voltage waveform, and this is the output voltage and current waveform. Already we told the inverter is the processing of DC to AC conversion. So in that conversion the voltage and current waveform here. So here the output is a 5 level inverter. So the output level is 5, 1, 2, 3, 4 and 5. So this is the output voltage waveform VA, VB and VC respectively, and next one is the output current IA, IB and IC respectively. And also using of 5 level topology we can reduce the total harmonic distortion. So here we can see the total harmonic distortion, the range is 0.96 percentage. So this is the total harmonic distortion. Compared to other method, this kind of reduction of the harmonic distortion is very low, so overall efficiency will be increases. So similar to 3 level and 7 level inverter is developed, and also the process will be given, and only the circuit topology will be changes. Thank you for watching this video.